Okay, number 13 says solve each system by graphing. So what the idea is to find, these are two functions, two linear functions, and the idea is to find the point where the two functions meet, or where they're both satisfied, the coordinate point that will, if plugged in, make both of these equations equal. So the first thing you want to do is, in this case, they're already solved for y equals mx plus b, so that's really nice. In number 14, they're not, so you would want to solve for y first, okay? So in number 13, I need to graph it. I've got the y-intercept -3, and then I've got a slope of 1, which is the same thing as 1 over 1, which means up 1 and to the right 1, or down 1 and to the left 1. Either way, end up in the same line. So we're going to go up 1 and over 1. And you need to go ahead and extend the whole grid. So we're going to go left and down as well, or down and left, and then connect. So there's the first line. And then the other one is y equals 7x plus 3, so the y-intercept is positive 3. And then the slope is 7, which is the same thing as 7 over 1, which means from a point I'm going to go up 7 and over 1, or down 7 and to the left 1. Okay? And since I don't have enough room to go up 7 and over 1, and obviously the intersection is not going to be over here, I'm going to go down 7. So from that point, 1, 2, 3, 4, 5, 6, 7, and over 1. And that puts me right there. And so I've graphed the two lines, and the point is to find the point of intersection, and we did. And so you actually need to go out to the side and write down what that coordinate point is. It's the coordinate point -1, -4, because that is your solution, okay? Anytime you're trying to solve a system, you're trying to find that point where they intersect, okay, the two lines. Okay, but there's different methods. So 13 and 14, you're solving by graphing. 15 and 16, you're solving using elimination. So if I were to solve using elimination, the idea is to eliminate a variable, okay? It depends on what you want to target. If you want to target x, then we'll target x. If you want to target y first, then you target y. It doesn't really matter. And I will go ahead and do both. Okay, so for this one, I'm going to target x, meaning I want to eliminate x. And with elimination, what you do is you end up adding the equations. And the only way a variable is going to be eliminated is if the coefficients are the same number, but one's positive, one's negative. So I've got a -8 and a positive 2. 2 actually goes into 8. All I need to do is multiply this whole equation by 4. I need an 8 here, but the only way I can multiply 2 times 4 is if I multiply the whole equation by 4. So I distribute that, and I'm left with this. -8x minus y equals -1, so that's the first equation. And then once I distribute the 4, I'm left with positive 8x plus 20y, and then equals 20. Okay, so I have made it to where two of the variables, x, well, one of the variables, but in both equations, they have the same absolute value, but one of them is negative, one is positive. So what we're going to do is we're going to add the two equations, and I've got -8 plus 8x, and that -8x plus 8x, and that gives me 0. Some people are putting 0x, so they were just putting x, but if you have 0 x's, that means you have 0, you have nothing, okay? A -1 plus 20 is a 19, so 19y, and again, a -1 plus 20, or 20 minus 1, is 19. I'm trying to solve for y, so I'm going to divide by 19. And when you divide by 19, you get y equals 1. Once you have that y equals 1, you can go up into either equation. It doesn't really matter, because the point is that when y equals 1, these two functions should be intersecting, so you should find the same x value. Okay? So I used the first one, -8x minus 1 equals a -1, so I plugged in y equals 1, not -1. Okay? So then I add 1 to both sides, and I get -8x equals 0. I divide by -8, and 0 divided by anything except for 0 is 0. So my answer is the coordinate point 0, 1. Always remember to put x first and then y. Okay, just to prove it to you, I'm going to plug in y equals 1 into the bottom equation. So if I have 2x plus 5 times 1 equals 5, so y equals 1 in the bottom equation, then that's 5, and if I subtract 5, I get, again, something times x equals 0. If I divide by 2, I would still get 0. Okay? Now let me show you the other way. What if, instead of targeting the x, I decided to target the y? So what's awesome about both of these situations is that I've got a negative and a positive, okay? If I were to multiply the top equation by a 5, then I have a negative 5 and a positive 5. So I'll go ahead and do that. So I've got negative 40x minus 5y equals a negative 5. And then I'll just rewrite the bottom equation. 2x plus 5y equals 5. Okay? So now I'm ready to combine like terms. Not combine like terms, add the equations. Sorry. Negative 40 plus 2 is like 40 minus 2, 38, only it's negative, so negative 38x. Those two are gone, and actually those two are gone too. But don't think that I don't know what to write. I just don't write plus 0 because I don't need to, but here I need to have something over there, so I've got to go ahead and write 0. If you're trying to solve for x, you want to divide because you're multiplying by negative 38. And then I've got x equals 0 divided by a number, and that is 0. Okay? Now once I have x equals 0, I can go back into my equations. I'll use the bottom one. 2 times 0 plus 5y equals 5. 2 times 0 is just gone. And then I would divide both sides by 5. And then we get y equals 1. Okay? So again, you would write your answer in that coordinate point. Okay. Number 16 is a little different because over here, like if I just multiplied 2 times 4, I got 8. And if I multiplied negative 1 times 5, I got negative 5, and that's what I needed. Over here, 6 does not go into 9, and 8 does not go into 12. So it's not so much what do I need to multiply one of the equations by, it's what do I need to multiply both of them by to get the same number. So let's go ahead and target x's. When I think about what number do they both go into, I think about the multiples of the larger number. So we've got 9, which 6 does not go into, but 9 times 2 is 18, which 6 does go into. This is a positive, this is a negative, so we already have that going for us. So I'm going to multiply the top equation by 3 to get a positive 18 here. I'm going to multiply the bottom equation by 2 to get a negative 18 there. So once I distribute, I get 18x plus 24y equals, no, why did I just do that? I was thinking dividing. Equals 18. Okay? Then on the bottom equation, I distribute the 2 and I get negative 18x, negative 24y, and negative 18. And then I add, and I get that those cancel each other out. Those also cancel each other out, so I've got to have something over here, so I'm going to put equals, or 0 equals. But then those also cancel each other out, so I get 0 equals 0, which is a true statement. And if I get a true statement, not like x equals, like over here, and not a false statement, but if I get a true statement, that means that these are actually the same lines right here. So it's just infinite many solutions because they always equal each other. Now I could have seen that if I noticed that this equation, I mean, do you see that they're all divisible by 2? So if I divided everything by 2, I would be left with 3x plus 4y equals 30. And then this equation, I've got negative 9x minus 12y equals a negative 9. If I divide all of them by negative 3, negative 9 divided by negative 3 is positive 3. Negative 12 divided by negative 3 is positive 4. And again, positive 3. They are the same line. So it makes sense that they would equal each other infinitely many times because they are the same thing. Okay? If you'd wanted to divide one of these by, like if you divided this by 2, and you don't need to know this, but say I had noticed that that was all divisible by 2. I could have written the top equation like that and then left the bottom equation like that. And do you see how that actually becomes an easier problem? Because all I got to multiply is this top equation by 3 to get a positive 9 to cancel out the negative 9. So if you notice it's divisible, then you can go ahead and get rid of it. Okay, the next number you want is 19. All right, if I said I was selling something for $5 a piece, and I sold 213 of them, 213 pieces, if you will. If I want to know how much money I made, I would just multiply the number I sold times the price. That makes sense, okay? So when I have something like the price, or the total amount I made, okay, so if I have the total amount I made and then I have the price of the two things that I'm selling, it makes sense that if I just said, well, if I multiply 250 times the number of large bottles, so if I put L equals number of large bottles, okay, so if I said $2.50 times the number of large bottles plus, and then if I let capital R be the number of regular bottles, so $1 times the number of regular bottles, then it should add up to how much money we brought in, $221. The other piece of information we got is that he sold 113 bottles altogether. Well, I sold L large bottles, and I sold R regular bottles, and so the number of large plus the number of regular should add up to 113. Okay? So we actually have a system of equations. And so we could solve that in a couple different ways. So I'm going to first address I'm going to address elimination, and then I'm going to do substitution, because it doesn't really matter how you do it. So if we do elimination, so if I have 2.5 L plus R equals 221, and L plus R equals 113. Elimination, you want to eliminate one of the variables. I could, if I wanted to, multiply the bottom equation to get rid of L's. I could just multiply the bottom equation by negative 2.5, all of it. Or I could just target the R's and make one of these negative. And I'm just going to go ahead and multiply the bottom equation by negative 1. So I've got 2.5L plus R equals 221. And now I've got negative 1L minus 1R, that's a positive 1, and then minus 113. Okay, so then I just add the equations. 2.5 minus 1 is 1.5, or 3/2. Those go away, and then 221 minus 113, so it's 108. 108. Let's see, if I just thought of it like 3/2, L equals 108, and I multiplied by 2/3. 108 divided by 3. 108 divided by 3 goes into it. 36 times, and 36 times 2 is 72. Okay. You could have typed that in your calculator, and you could have just divided 108 by 1.5. But I want to go ahead and work it out. So I got that the number of large bottles is 72. I think that's right. 216, so yeah, that's it. Okay. So, now that I've got the number of large bottles, I can find the number of regular bottles, because I know that I sold 100, or he sold 113 total. So if I've got 72 plus the number of regular bottles equals 113, then I'm just subtracting. So then 11 minus 7 is 41. So the number of regular bottles is 41. Now, when you're answering a problem like this, is how many bottles of each type did he sell? It would be very good, it would be very correct if you would actually answer your question with words. Because if you just say 72, 41, that doesn't really make sense. So I'm going to say he sold 72 large bottles and 41, I don't know what that was, regular bottles. And there you go. Okay, I did say I want to address it one more way, so if you're good with that, then move on, but I'm going to go ahead and show substitution. Okay, so if I had 2.5 L plus R equals 221, and L plus R equals 113. It really doesn't matter what variable you solve for. I'm going to go ahead and solve for, R in this equation, because why not? Okay, so I'm going to subtract L. So R equals 113 minus L. So in the top equation, where I've got 2.5L plus R equals 221, in place of R, I'm going to put what R equals in the other equation, 113 minus L. Okay? So what you'll find is that you get 2.5 minus 1, which is very similar to what we did right here. 2.5 minus 1, and that is 1.5 L. And then if I subtract 113 over, you find that again it's the same as this right here, 221 minus 113, and that is 108. And then I would divide by 1.5 or multiply by 2/3, because that is 3/2, and I would get the answer. Okay? So either method will get you in the same kind of situation. Let's talk about 20. All right, 20 says Mrs. Carney is selling tickets to a play. On the first day of ticket sales, the school sold 17 adult tickets, 8 senior citizen tickets, and 20 child tickets for a total of $236. The school took in $391 on the second day by selling 26 adult tickets, 12 senior citizen, and 41 child. How much would it cost for the Patson family to go if there are 2 adults, 2 senior citizens, and 3 children, if the adult tickets cost $8? Okay, so let's start this off. We want to know how much the tickets cost, knowing that the adult tickets cost $8, right? So if I said 17 adults, so we'll let adults be A, senior citizens B, we'll go capital S, although it looks like a 5, that's okay. And then child tickets be a capital C. So if I had 17 adult tickets, so 17, and I guess I should clarify. This is going to be the price. That's going to stand for the amount of money the ticket cost. Okay? Because that's what we're trying to figure out. If I know the ticket cost, then I can say how much the Patson family has to pay, right? So 17 tickets times the cost of the tickets, plus, so that's 17 adult, 8 senior citizens, so 8 times the cost of the senior citizen tickets, plus 20 times the cost of the child tickets, should add up to the $236 they took in that day. Okay? On the next day, they took in $391 by selling 26 adults, so 26 adult, 12 senior citizen tickets, and 41 child tickets. Okay? I'm going to go ahead and put senior citizen. Although I should have just done X, Y, and Z, or A, B, C, oh well. Okay. Senior citizen. Okay. So the only other piece of information they told me was that the adult tickets cost $8. So if I can go ahead and replace that cost with $8, then I can go ahead and take away the money spent on, or the money gained by selling adult tickets. And then I only have senior citizen and child tickets as part of the situation. So I would multiply, I sent all my calculators away. Okay, let me go grab them. Okay, so if I do 17 times 8, I get 136. So I have 136 plus 8 senior citizen tickets plus 20 child tickets equals 236. So I would subtract 136, and I would be left with 8 senior citizen plus 20 child equals $100. So they made $100 after from selling just those. Okay. Now let's do the bottom one. Okay. 26 times 8 is 208. So that's 208 plus 12 senior citizen tickets plus 41 child tickets equals 391. So if I subtract 208, so 391 minus 208, I've got 12 senior citizen plus 41 child, 91, so 17 is 7283, 183, what am I doing? I'm gonna make sure. 391 minus 208. Okay, so now we're into a system of equations with two variables, and you can do what we did before with elimination. You could do with substitution. It really is kind of up to you. I'm going to actually kind of play around with this. Now, if you notice, 8, 20, and 100 are all divisible by 2. And if I were to divide them by 2, I would have 4, 10, and 50. And that is actually kind of nice, because then 4, all I got to do is multiply by 3, and I can cancel out the 12s. But not many people are going to notice that, so I'll just go ahead and deal with it. 8 senior citizen plus 20 child equals 100, and 12 senior citizen plus 41 child equals 183. I'm just going to go ahead and cancel them out. What do both 8 and 12 go into? 24. 12 times 2 is 24. If I multiply the bottom equation by 2, I get 24. And if I multiply the top equation by 3, I get 24. But 24 plus 24 does not equal 0. I need one of them to be negative. Does it matter which? No. So I'll just go ahead and do the top equation. Doesn't really matter. You could have picked the bottom equation, okay? So I distribute, and I'm going to get a negative 24 senior citizen, a negative 60 child, and then equals a negative 300. And now I'm going to distribute 2. So I've got positive 24, let's see, 82 plus 82, and then 2 times 183, 2 times 18 is 36, so 366. Okay, so then I add the equations. Alright, now the 24s are gone. Negative 60 plus 82 is like 82 minus 60, that's just 22. And then 366 minus 300 is 66. So then I divide by 22. And I get that child equals, well, C equals 3. So let's talk about what the variable stood for. The variable stood for the ticket cost. So this means that a child's ticket is $3. Okay? Now, once I know how much the child's ticket costs, then I can use that to solve for the senior citizen ticket. I'm going to go up to this top equation. 8 times the cost of the senior citizen tickets plus 20 times the cost of the child tickets, which we now know is 3, equals $100. So that's 60. So I'm going to subtract 60 and get 40 equals 8 times the senior citizen tickets. And then we divide by 8, and you get that the senior citizen ticket costs $5. Okay, so the final question is, how much will the Patson family have to pay to go if there are 2 adults, 2 senior citizens, and 3 adults? 3 child, sorry. Okay, so they have 2 adults, 2 senior citizens and 3 children. So that's going to be 2 times the adult ticket cost, $8, plus 2 times the senior citizen cost, which is $5, and 3 times the child cost, which is 3. So that is 16 plus 10 plus 9. Okay? So that is 26 plus 9, that is $35. And there you go. That's a long one, but I enjoyed it. Okay. All right, let's talk about 21. 21 says 5x to the 4th plus 2x minus 4x squared minus 3x times the quantity x plus 2x squared minus 7x cubed. So the idea is going to be to simplify and then combine like terms. Okay? So the only thing I can see that I need to do first before I can start combining like terms is distribute this right here. So I'm going to distribute a negative 3x to x and a negative 3x to 2x squared. So I've got 5x to the 4th plus 2x minus 4x squared. A negative 3x times x is a negative 3x squared. X times x is x squared. And then negative 3x times 2x squared is a negative 6x times x squared is the same thing as saying x times x times x, which is just x cubed. So we're just adding the powers. Okay? So that's 6x cubed and then minus 7x cubed. So the idea is to combine like terms, and the only way you can combine, the way you find like terms is by the powers. Okay? I'm going to go with the highest power first. The highest power I see is 4, so that's going to be my first, the first part of my answer. Okay? The next highest power, the next power I see is cubic, the power of 3, and there's 2 of them. So negative 6x cubed minus 7x cubed is like adding 2 negatives. I've got negative 6 of them and negative 7 of them. That means I have negative 13x cubed. Okay? X cubed. Okay, then I have the squares, and I have 2 of those. So I've got negative 4 and negative 3. That's a total of negative 7x squared. And then I've got the 2x. And so that is the final answer for that. Okay. Let's go to 27. So 27 says to solve for r. And this is the volume formula for a sphere. So one way to think of this to make it easier on yourself is as this, 4 pi r cubed all divided by 3, because that is exactly what is happening. I'm multiplying, well, if I were to take a radius and plug it in, I would cube it, I would multiply it by pi, multiply it by 4, and divide it by 3. So everything is divided by 3. So in order to undo that division, you multiply. So I'm going to multiply both sides by 3. And you can look at it like this and just think, okay, those simplify out. Or you can think of it like this, and then those simplify out. Either way, you end up with 3v equals 4 pi r cubed. Now r has 2 different things acting on it right now. It is being raised to the power of 3, and then it's being multiplied by 4 pi. So think about what I would do first if I plugged in a number. If I plugged in a 2 right here, I wouldn't say 2 times 4 pi and then raise it to the 3rd power. I would raise it to the 3rd power first and then multiply by 4 pi, which means I need to get rid of 4 pi first. You need to get rid of the outermost thing. We are multiplying by 4 and pi, or by 4 pi. So the opposite of multiplication is division. So I've got 3v over 4 pi equals r cubed. Well, you've done it over and over in geometry, that if you were solving the quadratic, not the quadratic, the Pythagorean theorem, a squared plus b squared equals c squared, and you were trying to find the hypotenuse, you just square rooted both sides to get rid of the square, right? Well, there's an understood 2 right here on the square root. So if I'm trying to get rid of a 3rd power, I just take the 3rd root. Okay? So then those cancel each other out, the operations do. So I'm left with the cubed root of 3v over 4 pi equals r. And there you go. Okay, 28. 28 says solve for p sub 1. So right now, I am multiplying, well, okay, piece of 1 is being subtracted from piece of 2, and that quantity is being multiplied by 0.05. If you wanted to, you could distribute 0.05, and I might show that in a second, just in case anyone does that and wants to see it. Okay, but the other option is to just go ahead and divide it out. So if I divide both sides by 0.05, then I can say p divided by 0.05 equals, those are gone, so I'm left with p sub 2 minus p sub 1. I no longer need that parentheses, because I'm no longer multiplying. I want to get rid of the p sub 2, and right now we're adding it to the side. It's got a plus sign, so it's understood plus sign. So we'll subtract p sub 2 from both sides. So that means I'm left with p divided by 0.05 minus p sub 2 equals negative p sub 1. A lot of people forget that negative, but it's still there. Now, in order to get rid of a negative, you can think of it as a negative 1 being multiplied by p sub 1. And the opposite of multiplying by negative 1 is to divide by negative 1. So divide both sides by negative 1. But dividing by negative just changes the sign. So this becomes a negative p divided by 0.05. This becomes a positive p sub 2. And then there you go. Okay? Let's try it if you distribute, in case anyone does that. Because it's not wrong, it's just a matter of what you do after what you've done. Okay? So say you distributed 0.05. Then you would have 0.05 p sub 2 minus 0.05 p sub 1. Okay? Then you would subtract this, 0.05 p sub 2, 0.05 p sub 2, and you're left with p minus 0.05 p sub 2 equals negative 0.05 p sub 1. And then you want to solve for p sub 1, so you divide by what you're multiplying by, negative 0.05. So if I looked at this, if I split this up, I would be okay with this as an answer except for the negative. I would float the negative to the top and make that negative and make that positive. So I would say negative p plus 0.05 p sub 2 divided by 0.05. That's fine. But if you also just split up the fraction, this divided by that, p divided by negative 0.05 is just a negative p divided by 0.05. And then that divided by that is just 1, so plus 1 p sub 2, right? And that's what we got, right? Negative p divided by 0.05 plus p sub 2. So either way, if you stopped right here, that's fine. If you stopped right here, that's fine. I don't necessarily like that because of the negative in the denominator, so I would want you to float that to the top. Okay? Or if you didn't want to have to deal with it, you could have added this over. Added the 0.05 p1 over, and then subtracted the p over, and then you wouldn't have to deal with that. Division by a negative. Okay. All right, 29. 29 says to solve for C, and this is the formula to convert between Celsius and Fahrenheit. So C is inside here. We're subtracting 32, and then we're multiplying by 9/5. I'll go ahead and take it separately, but if you're cool with it, you can say the opposite of multiplying by 9/5 is to multiply by 5/9. But here we go. We're dividing this by 5. We're dividing 9 by 5, but we're in fact dividing everything by 5. So I'm going to multiply both sides by 5. And then those will go away. And so what I'm left with is 5f equals 9 times c minus 32. I'm multiplying that expression times 9, so I'll go ahead and divide it out. So I'm left with 5f divided by 9 equals, I no longer need the parentheses because I'm not multiplying anymore, c minus 32. And then I need to solve for c, so I add the 32 over. So final answer, 5/9 f, or 5f over 9, plus 32 equals C. Okay. Number 36. So number 36 is factoring, and that C right there is my notation for for the fact that I would allow you to use a calculator on that. Some of these I would not allow you to use a calculator. I'm not necessarily going to take it away from you on this quiz, but I will in the future. Okay? So, first off, the thing about it is that 35, 205, and 150, anytime you're trying to factor, you need to see if they have a common factor. And that has a 5 at the end, a 5 at the end, and a 0 at the end, so that tells me they're all divisible by 5. Now, this is 5 times 7, 35, and I know those aren't divisible by 7. So I'm going to factor out a 5. Okay? So I factor out a 5, and 35 divided by 5 is 7, so 7r squared. 205 divided by 5 is 41. And 150 divided by 5 is 30. Okay? So I'm going to forget about the 5. 5 is part of my answer, but I don't need it anymore. Okay? It's not part of the process. At this point, my job is merely to factor that. Okay? So forget about 5. Okay. So I'm going to do bottoms up. I'm going to multiply 7 times 30, and that is 210. And I'm looking for the factors of 210 that add up to the middle term, positive 41. Okay? If you are unsure about how to find factors, you can just start dividing. 210 divided by 2, 210 divided by 3, 210 divided by 4, 210 divided by 5, or you can go to y equals and just type in 210 divided by x. Okay? Sorry, you couldn't see that. And then go second graph and second table. And I look and I see, okay, 1 and 210, 2 and 105, 3 and 70, 5 and 42, 6 and 35. And I'm trying to add up to 41. So I think those are it. I don't think, I know. Okay. And I don't have to worry about signs because they're both positive, positive 210, positive 41. So bottoms up says that I write r plus 6 and r plus 35. But because I multiplied by 7, that is the thing I divide out. Okay? Now, 6/7 does not simplify, which is why it's called bottoms up. I bring the 7 up there. So 7r plus 6. 35 does divide by 7. That is 5. And so that is my final answer. Now, I have space, so I'm going to check it. Because I want to make sure. Okay, I am going to distribute. Okay, one thing to be clear on, I'm not going to, if I distribute the 5 first, it's not to both of them, okay? The only time you distribute is when there's a plus sign in between them. So if I had 5 times 2 times 3, it would just be 10 times 3, which is 30, right? You wouldn't say 5 times 2 times 5 times 30. You would just say 5 times 2 times 30, okay? So I'll go ahead and distribute my 5 to this 2. So 35r plus 30 times r plus 5. And I get 35r times r. That's 35r squared. That's promising. I get 35 times 5, which is 150 and 175. Yeah, 175r. And then I get 30 times, so I distribute 35r to both of those. Now I'm going to distribute 30. 30 times r is 30r. 30 times 5 is 150. And if I combine those middle two terms, I get 205. So we're good. Okay, and I was right. Okay. Let's go to number 49, which I already did, so I'm going to put it right here. Okay. So 49 is the quadratic formula, and you've got the function 6k squared minus 4k minus 5. So the idea is to solve ax squared plus bx plus c equals 0 using the quadratic formula, which is x equals negative b plus or minus square root of b squared minus 4 times a times c divided by 2a. All of it. I saw a lot of us not writing the division symbol over the negative b, and that really needs to happen. Okay? Notice the a, b, and c do not involve the x's. They are the numbers in front of there, the coefficients. So a here is 6, b is negative 4, and c is negative 5. okay? So if I'm filling out the quadratic formula, normally I would say x equals, but because it was k, I'm going to say k equals. K equals. Now this says negative b. Well, if b is already negative, then that's a negative negative, which makes it a positive. So that is positive 4 plus and minus the square root of b squared. So that's negative 4 squared minus 4 times a, which is 6, times c, which is negative 5, divided by 2 times a, which is 6. Now, if you have your calculator with you, and if I allow you to use it, then I would expect you to type that in your calculator. Negative 4 squared. Just the stuff inside the square root, not the actual square root, okay? Negative 4 squared, or just positive 16. If you know it's 16, just write 16. Minus 4 times 6 times negative 5. And I get 136. So I've got 4 plus and minus the square root of 136 divided by 12. Now, 136 is not a perfect square. It's not in my list, but it's even, so it could be that it has a perfect square that divides out of it. So we're going to go ahead and check. Now, in my list of perfect squares, I've got 144, and then 121, and then 100, and then 81, 64, 49, 36, 25, 16, 9, 4, right? My advice to you is always try to find the largest one. So 136 is between these two. It does not, 121 times 2 is way bigger than that, so it's not that. 100 times 2 is 200, so it's not that. 81 times 2 is 160 something. 64 times 2, 6 times 2 is 12, so it's not 136. If you're unsure, then you start checking. 136 divided by 49. 136 divided by 49. Nope. 136 divided by 36. Nope. 136 definitely does not divide by 25, so I'll try 16. Divided by 16. I'm at the school and they're setting off fireworks, so sorry if you hear my dogs bark. Okay, 136 divided by 9. Nope. And 136 divided by 4. If it doesn't, then we're done. But it does. 4. So what I know is that this is the same thing as 4 times 34. And the square root of 4 is 2. So I've got 4 plus and minus 2 square roots of 34 divided by 12. Okay? Now if these numbers, let's see. I don't have a light purple. Thought I did. Oh well, whatever. If this number, and this number all divide by the same number, then I can simplify it out. Kind of like if I had 4 plus 2x over 12, right? If you did that, then you could say 4/12 plus 2x over 12. And you could say that's 1/3 and that's 1/6. But what you can't do is say, oh, that's 1/3, and then say that's 2/3. No, it's not. It's 1/6, right? If you split it up separately. But because we're not going to split this up, it has to be something that all three numbers are divisible by. They're all divisible by 2. So if I divide that by 2, I'm left with 1. 2. If I divide that by 2, I'm left with 1. If I divide that by 2, I'm left with 6. So my final answer is 2 plus and minus the square root of 36, or 1 square root of 36, all over 6. And that, 36. I just misspelled 34. And mispronounced it. Okay, so then that is my final answer. Okay. So, number 52. Number 52 is not set equal to 0. So the first thing you want to do is get it set equal to 0. We want to subtract 2x from this side, and we're going to go ahead and put it right here because that's the term it's going to combine with. So I've got x squared minus 5x minus 6 equals 0. So a is the number in front, that's 1. B is negative 5, and C is negative 6. So I've got x equals negative b, it's already negative 5, so positive 5 plus or minus the square root of b squared. Now I'm going to write negative 5, quantity squared, but if you want to go ahead and write 25, you totally can. Just make sure you make it positive, okay? So negative 5 squared minus 4 times a, which is 1, which you don't have to write, and then times c, which is negative 6. all over 2 times a, which is 1. Again, you don't have to write it. So I type that in. Negative 5 squared, or 25, minus 4 times 1 times negative 6. And you get 49. So 5 plus and minus the square root of 49 all over 2. Okay? Well, you're not done in this case because we should always check to see if you can simplify. But 49 is actually a perfect square. And the square root of 49 is 7. So this is 5 plus and minus 7 over 2, which literally means one of my answers is 5 plus 7 divided by 2, which is 12 divided by 2, which is 6. And the other answer is 5 minus 7 divided by 2, which is negative 2 divided by 2, which is negative 1. So my two answers are this. Okay? There you go. All right, last two. 55, it says graph the inequality, and I've got this linear inequality, 2x minus 5y is less than 10. Okay? When you are graphing an inequality, the idea is that you are shading and you are figuring out every single point for which this inequality holds true. Okay? So the first thing I want to do is I want to solve for y. Okay? And pretend like this inequality was an equal sign. Let's just talk about that. So first I would subtract 2x, and I'm left with negative 5y is less than negative 2x plus 10, or 10 minus 2x, doesn't really matter. I'm trying to solve for y, so I need to divide by this negative 5. And I get y, and then I get 2/5 x, because that's positive, and then minus 2. Okay, so if this is an equal sign, then I would just graph the y-intercept is negative 2, and the slope is 2/5, though, up 2 over 5. And to go up 2 and over 5 is to the right 5 is the same thing as to go down 2 and to the left 5. Okay, now, as far as shading goes, this right here says less than, right? But I'm going to go ahead and figure out which points actually make this work, okay? I'm going to go ahead and check the point 0, 0, right there. So if I plug in x equals 0 and y equals 0 into this right here, then that means, and it works out, then that means it's part of my solution set. So this says 2 times 0, which is 0, minus 5 times 0, which is 0, is less than 10. And 0 is less than 10. Now, if I were to put a less than symbol here, that makes me think that I'm going to shade below the line. But because I divided by a negative, I have to flip the inequality. So then you can see that it actually does make sense that 0, 0, which is above the line, fits in my solution set. Okay? Now, another thing. It says greater than. It doesn't say greater than or equal to. So if I actually plugged in a point on the line, like the point 50, marbles. Marbles. Okay. If I plugged in the point 50, and I plugged in 5 right here, so 2/5 times 5 minus 2 and 0. This is 0. It says 0 is greater than 0. That is not true. Okay, so we're not including the line, which means when I connect them, I should connect them with a dotted line. And then when it says, my final answer says greater than, so I'm going to shade above. You can just shade with a pencil, you can shade with a highlighter, you can shade with whatever, but that is the answer, okay? Alright, so last one. I've got negative 7x plus 2y is greater than or equal to 15. I want to solve for y, so I'm going to add 7x to both sides, and I'm left with 2y is greater than or equal to 7x plus 15, and then I need to divide by 2. So if I divide by 2, then I'm left with y is greater than or equal to 7 over 2x plus. Now, I like to leave the number in front of x, the slope, as a fraction because it makes sense, up 7 over 2. But this is a y-intercept, 15 cut in half. So 14 cut in half is 7, 16 cut in half is 8, so 15 cut in half is 7.5. I need to actually plot a point, and it makes sense to go to 7.5 on the y-axis versus 15/2. So I'm going to go to 7.5 and plot a point. Now my slope is 7/2, which means up 7 and to the right 2. But I don't have enough room, so I'm going to go down 7 and to the left 2. So I'm going to go down 7. 1, 2, 3, 4, 5, 6, 7, and over 2. 1, 2, 3, 4, 5, 6, 7, and over 2. This says greater than or equal to, so that means we're including the line. I didn't actually go through the split, but there we go. Okay, and then we're supposed to shade, well, it says greater than or equal to. So what I always say is, and this is a little, I mean, it's steep, but at the same time, there's still definitely something that's above it. If you pick a point on the line and draw an arrow up, like straight up and down, if it points up in that direction, we're on that side of the line. That means that's the region that we shade. And there you go. There's your answer. Okay, I hope this helps.